What if the reason we haven't found aliens isn't because they don't exist, but because finding them would be the last thing we ever do? The universe is 13.8 billion years old. Our galaxy alone holds over 100 billion stars. And yet, when physicist Enrico Fermi asked the question, "Where is everybody?" back in 1950, he wasn't being philosophical. He was doing math. The numbers say civilizations should be everywhere. The silence says otherwise. That contradiction is called the Fermi paradox, and scientists have spent decades trying to solve it. What they've come up with isn't comforting. In fact, some of the most statistically plausible explanations for why the universe is so quiet are the exact scenarios that should terrify us the most. Today, we're walking through the 6 alien contact scenarios that scientists consider statistically possible. Not science fiction, not conspiracy theories. Actual hypotheses backed by mathematics, physics, and the cold logic of probability. These aren't the aliens from movies. These are the aliens the equations predict. And by the end of this video, you might understand why the silence of space is the most terrifying sound in the cosmos. Before we dive in, if you're the kind of person who stays up at night thinking about what might be lurking in the dark between stars, hit that subscribe button and turn on notifications. We're exploring the edge of what's possible. And trust me, you don't want to miss what comes next. Scenario 1. The Berserker probes. Any civilization that survives long enough will eventually develop self-replicating probes. These are machines that travel to a star system, harvest local resources, build copies of themselves, and send those copies to new star systems. It's called a von Neumann probe, named after mathematician John von Neumann, and it's not theoretical science fiction. We are already discussing similar concepts for exploring our own solar system. The Breakthrough Starshot project, for example, proposed using laser-propelled nanocraft to reach nearby stars. Here's where it gets dark. A computer simulation published in the Journal of the British Interplanetary Society found that a single self-replicating probe could explore 99% of all star systems in the Milky Way in just 5 million years. 5 million years sounds like forever to us, but the Milky Way is over 10 billion years old. That's a fraction of a percent of the galaxy's lifetime. So if even one civilization, anywhere in the galaxy's history, built these probes, they should be here by now. Everywhere. In every star system. Including ours. The Berserker hypothesis asks, what if they are here, and what if they're not friendly? What if these probes are programmed not to explore, but to exterminate, to seek out emerging technological civilizations and eliminate them before they become a threat? It's the ultimate preemptive strike, automated and eternal, sweeping through the galaxy like a cosmic immune system. The reason we don't see aliens isn't because they don't exist. It's because the probes got to them first. And if that's true, the only reason we're still here is because they haven't found us yet. Or maybe they have, and we're just not worth the energy. Yet. Scenario 2. The Dark Forest. The universe, according to this model, is like a dark forest at night. Every civilization is a hunter, moving silently through the trees. Each one knows that other hunters exist, but no one knows if the others are friendly or hostile. The safest strategy, the only rational strategy, is to shoot first. Not because you're aggressive, but because survival demands it. If you reveal your position, if you broadcast your existence into the cosmos, you're taking an existential gamble. You're betting that whoever hears you will be benevolent, but evolution doesn't produce benevolence. It produces survivors, and survivors don't take unnecessary risks. In 1981, cosmologist Edward Harrison argued that any intelligent species that has overcome its own self-destructive tendencies would view any other species bent on expansion as an existential threat. Not because of malice, but because of math. Resources in the universe are finite. Technology accelerates exponentially. A civilization just a few thousand years ahead of you could be unstoppable. So the logical move is to eliminate competitors before they become threats. The silence of the universe isn't empty. It's a battlefield where everyone is hiding, everyone is armed, and the first one to make a noise dies. That's why we haven't heard from anyone. They're not ignoring us. They're being very, very quiet. And the moment we broadcast a loud enough signal, the moment we truly announce ourselves to the galaxy, we might find out exactly why silence is the universal standard. Scenario 3. The Great Filter. If the filter is behind us, if it happened somewhere in Earth's deep past, then we're incredibly lucky. Maybe the jump from prokaryotic to eukaryotic cells is nearly impossible. Maybe the Cambrian explosion was a 1 in a trillion event. Maybe complex life is so rare that we're effectively alone. That's the rare Earth hypothesis, and while recent discoveries of thousands of exoplanets have weakened it, astrophysicist Matt O'Dowd has identified eukaryogenesis as a reasonable candidate for such a filter. But if the filter is ahead of us, if it's something every technological civilization hits just as they're about to expand into space, then we're in trouble. Nuclear war, runaway climate change, uncontrolled artificial intelligence, synthetic biology gone wrong. These are all candidates for the Great Filter. And the terrifying part is that every single one of them is a problem we're currently facing. The reason we don't see alien civilizations isn't because they never existed. It's because they all destroyed themselves before they could leave their home planets. And we're next in line. A 2025 study by Manuel Scherf and Helmut Lammer found that for even one technological civilization to exist in the Milky Way at the same time as us, that civilization would need to survive in a technological phase for at least 280,000 years. We've been technological for about 200. We're not even close. The Great Filter might not be a single event. It might be a gauntlet, and we're just beginning to run it. Scenario 4. Directed panspermia. The idea is that life on Earth might not have originated here. Instead, an advanced alien civilization might have seeded life across the galaxy by sending out probes loaded with microorganisms, or even engineered DNA designed to take root on suitable planets. It's not as far-fetched as it sounds. We already know that extremophils, microorganisms that can survive extreme conditions, could theoretically survive interstellar travel. And if a civilization was advanced enough, they could encode information into genetic material, essentially sending a message that unfolds over billions of years as life evolves. But here's the darker version of this scenario. What if we're not just a science experiment? What if we're a farm? What if the civilization that seeded us is waiting for us to reach a certain level of development before they harvest whatever it is they need? Intelligence, resources, or something we haven't even conceived of yet. The reason they haven't contacted us isn't because they don't know we're here. It's because we're not ripe yet. And when we are, the harvest begins. Even if the original seeders are long gone, their automated systems might still be active. The universe could be full of ancient, dormant machines waiting for their crops to mature. We might be one of thousands of seeded worlds, all ticking toward the same unknown deadline. Scenario 5. The simulation contact. This scenario doesn't require aliens to be physical at all. In fact, it questions whether physical reality is even the baseline. It's the simulation hypothesis, first seriously proposed by philosopher Nick Bostrom in 2003, and it's gained serious traction among physicists and technologists. The argument goes like this. If any civilization anywhere in the universe ever develops the ability to run realistic simulations of conscious beings, and if they run even a small number of them, then statistically, simulated minds will vastly outnumber biological ones. Therefore, the odds that we are living in a simulation are overwhelmingly high. Elon Musk has famously said that the odds we're in base reality are 1 in billions. And if he's right, then aliens might not be extraterrestrial. They might be extra-dimensional. They might be the programmers. The planetarium hypothesis, proposed by scientist Stephen Baxter, takes this even further. What if the reason we don't see aliens is because the simulation we're in was designed that way? What if the simulation is a controlled environment, a cosmic laboratory where we're being observed in isolation? The silence of space isn't empty. It's a boundary condition, a wall in the code. And the moment we detect something that shouldn't be there, a signal that breaks the simulation's parameters, we might trigger a system response, a reboot, a patch, or a deletion. This isn't paranoia. It's probability. If simulated universes are possible, and if they're easier to create than real ones, then most universes are simulations. And most aliens are either simulated entities like us, or the entities running the simulation. Contact wouldn't be a meeting of equals. It would be a bug report. Scenario 6. The cognitive horizon. We've spent decades scanning radio frequencies, looking for megastructures, searching for biosignatures in exoplanet atmospheres. But what if alien intelligence is so radically different from ours that we wouldn't recognize it even if it was right in front of us? What if it exists in dimensions, forms, or states of being that are fundamentally beyond human perception? Not because it's hiding, but because our brains, our instruments, and our science are built on assumptions that don't apply. Rakic argues that the Fermi paradox is too narrow. The real question isn't why we haven't perceived extraterrestrial life. It's what might exist around us that we are incapable of perceiving. Our search for aliens assumes they'll be carbon-based, or at least physical, or at least detectable by electromagnetic radiation. But what if they're not? What if they're patterns in quantum fields? What if they're processes in dark matter? What if they're the structure of space-time itself, conscious in ways we can't comprehend? This isn't mysticism. It's epistemology. We know there are limits to what human minds can grasp. We know that our senses evolved to track predators on the African savanna, not to perceive the full spectrum of cosmic reality. The cognitive horizon hypothesis suggests that the universe might be teeming with life, with intelligence, with civilizations beyond number, and we simply lack the cognitive architecture to detect them. We're not alone. We're just blind. And if that's true, then first contact won't be a message from the stars. It will be a paradigm shift in our own minds. A breaking of the cognitive horizon. And when that happens, everything we think we know about the universe will have to be rewritten from scratch. So there you have it. 6 scenarios, all grounded in real science, all statistically possible, and all deeply unsettling. The berserker probes, the dark forest, the great filter, directed panspermia, the simulation, and the cognitive horizon. Each one offers a different answer to the same haunting question. Why is the universe so quiet? But here's the thing. Every single one of these scenarios has a common thread. Survival. Whether it's surviving hostile probes, surviving the silence of a predatory cosmos, surviving our own technology, or surviving the limits of our own perception. The story of humanity in the universe is a story of survival against odds we barely understand. And that brings me to something. If you found these cosmic threats fascinating, you need to understand something. The universe doesn't just threaten us with distant aliens and theoretical filters. It threatens us with real, documented events that came terrifyingly close to ending everything. Events where the only reason you're watching this video right now is because of pure blind luck. I made a video about exactly that. It's called 10 Space Events That Almost Ended Humanity. We survived by pure luck. And I'm not exaggerating when I say it will change how you look at the night sky. Solar flares that missed us by hours. Asteroids we didn't see coming until they were already past us. Cosmic radiation bursts that could have stripped our atmosphere bare. These aren't hypotheticals. These happened. And the math says they will happen again. The link is right there on screen and in the description. Click it. Watch it next. Because understanding how close we've already come to extinction is the first step to understanding how fragile our place in the cosmos really is. And if you made it this far, I know you're the kind of person who needs to see it. I'll see you over there. And remember, the universe is quiet, but it's not empty. Stay curious, stay vigilant, and keep looking up.